so imagine this. You're all set to build your dream home. You've got to deal with the builder, the custom foundation is poured and ready, and then the whole thing just falls apart. Now you're left with this weirdly shaped concrete slab for a house that's never going to be built. What do you even do? Well, today we're going to look at a project that took that exact nightmare scenario and turned it into an amazing opportunity, all thanks to 3D printing. Let's get into it.
And this is where it all starts. Not with a fresh plot of land, but with an existing leftover foundation. It's a custom footprint, basically an orphan slab. Now, building on top of someone else's work is a huge challenge. Every single measurement is already locked in. You can't just change the foundation, so you have to completely change your thinking about the house that's going to sit on top of it.
All right, so here's how we're going to break this down. First, we'll look at the big challenge, that orphan foundation. Then we'll jump into the digital blueprint that was designed to solve the puzzle. After that, we'll get into the nitty-gritty of the printed walls, watch the build happen layer by layer, and finally see the finished house actually take shape.
Okay, section 1. The real trick here wasn't just building a house. It was building a house that could fit this exact pre-existing slab. And that's a job that demands some serious precision.
This note, pulled right from the architectural plans, is everything. It's basically the architects telling the new team, hey, don't trust the old plans. Don't assume anything. They had to go out there and physically measure every single surface, every pier, every wall. This was the absolute first step to making sure this leftover slab could actually work.
So let's get to the solution. And it doesn't start with concrete. Not yet. It starts with code. How do you possibly design a modern home to perfectly hug an old, unchangeable footprint? You gotta go digital.
And here it is, the result of all that digital work. This is no off-the-shelf floor plan. Nope. This is a completely custom blueprint where every single line you see was dictated by that concrete slab we just saw. The living room, bedrooms, kitchen, everything is meticulously mapped to line up perfectly with what's already on the ground.
And just to give you a feel for the space, check out these numbers. You've got a really nice 250-plus square foot kitchen, a cozy living area, 2 good-sized bedrooms. They somehow managed to design a totally functional modern space inside the rigid lines of that old foundation. I mean, that's just some top-notch architectural problem solving.
So how were they planning to actually build this custom fit design? The answer's right there in the plans. 10-inch thick, 3D printed concrete walls. They decided to use a machine called the Maxi printer, and that was the key. This kind of tech gives you the precision you need to trace that existing foundation perfectly, something that would be super difficult, not to mention expensive with traditional wood framing.
And that brings us to the technology itself. I mean, what is a 10-inch thick 3D printed wall, really? And how in the world is it strong enough to hold up a whole house?
This diagram is fantastic because it gives us a look right inside the wall. What we're seeing is a cutaway of a window opening, and it shows you that these walls are way more than just squiggly lines of concrete. It's a hybrid system, combining the new school tech of 3D printing with old school, proven reinforcement.
Let's break down the main parts. First, you have the 10-inch printed wall itself. That's what creates the shape. But look closer. See the steel running up through it? That's vertical rebar for strength. Then, inside the wall cavities and over the window, you have a rebar cage and a solid concrete lintel. The whole thing is designed to work together as one super strong system.
Now, that word lintel, it's super important. A lintel is basically a structural beam. It sits on top of an opening, like a window, and its whole job is to carry the weight from above and spread it out to the sides. In this design, it's a solid block of reinforced concrete, making sure those window openings don't create weak spots. Okay, now for the part we've all been waiting for. Let's watch this digital blueprint and this high-tech wall design actually turn into a real building, literally rising up from the ground. And here we are, day 1. The Maxi printer, which is this giant robotic arm, gets to work, squeezing out the very first layers of concrete. It moves with unbelievable precision, tracing the foundation's outline perfectly, turning that digital floor plan into the first few inches of a real wall. By day 2, the progress is just, wow. The walls are already a few feet high, and you can really start to see that unique, layered texture that's become the signature of 3D printed buildings. Every one of those lines is another pass of the printer, building the house up one bead of concrete at a time. Now jump ahead to day 4. It's almost hard to believe. The entire wall structure for the first floor is basically done. The rooms are defined, you can see where the doors go.
I mean, what would take a traditional framing crew weeks to do, they knocked out in just a handful of days. The speed here is a total game changer.
So after just 4 days of printing, the hardest, most labor-intensive part of the build is already finished. Let's take a look at the final result of this incredible process.
Standing on the ground, you really get a sense of the scale. This isn't just a concrete slab anymore, it's the skeleton of a house. You can literally walk through the doorways, stand in what will be the living room, and see the whole vision coming to life. It's now ready for the roof, the windows, and all the finishing touches.
And here it is, the money shot. This view from above shows you just how perfectly the printed house matches the foundation and that digital blueprint we saw earlier. Every single wall is exactly where it was supposed to be. It's just an amazing visual of how accurate this technology can be.
So what's the big takeaway here? A project that started with a massive headache, this orphaned foundation, was completely saved. Thanks to some clever design and incredible construction tech, it became a custom home printed in a ridiculously short amount of time and perfectly molded to its one-of-a-kind starting point.
It really makes you think, right? This tech didn't just work on some perfect, clean construction site, it solved a messy, real-world problem. So if you can print a house on a foundation it was never designed for, what are the limits? What other challenges in construction could this technology unlock next?